All right, well, I'll go ahead and kick it off. Thank you everyone for joining us today. My name is Lauren McCullough. I'm one of the members of the Arpio team. We appreciate everyone taking the time to join with us today. I know we have attendees I saw in the registration from all over the world, so I'm not sure if it's afternoon or maybe evening where you're at, but I appreciate you guys taking the time to join this class today. So as you saw in the registration, we're going to be discussing engineering for global redundancy, so we can help cloud engineers and architects like yourself really understand improve your understanding of multi-region architecture techniques. So we do have this course scheduled for the full hour, but we are going to make sure we allocate some time at the end for some questions. But if you have questions as we're going through the content, feel free to use the Q&A button on the bottom of your screen, and you can ask questions there either with your name or ask them anonymously, whichever you prefer. And I think with that, I'm going to go ahead and kick it over to Doug Newman. So Doug is the CEO of Arpio, and Arpio, as you may be aware, is a global redundancy software solution for AWS. Doug has about a decade of experience probably working with cloud technologies and AWS, probably about what I think it started in 2006. It's something like that. So probably about since it got started.
Okay, I'm trying to count gray hairs to figure out if we can determine it from that, but.
Yeah, we won't throw his age under the bus today, but so I'm going to kick it off to him. So he's going to handle most of the content today. But like I said, I will be here to monitor any questions y'all have throughout. So go ahead, Doug.
Great. Awesome. Thank you very much, Lauren. And thanks to everybody for sharing some time with us today. I hope that we can put on a good show for you and teach you some stuff about how you take existing or build new workloads in a globally redundant manner. And so just kind of to kick off, I wanted to start with just a couple introductions. My name is Doug Newman, and I'm joined with my colleague, Shaw Terwilliger. Shaw and I have worked together for years. This is the third company that we've worked at together. And a couple years ago, Shaw and I were having a conversation and sort of realized we've been solving this global redundancy problem in a few different contexts. And that it's a problem that people kind of have a hard time getting their head around and understanding how is it that I take my workload and make it globally redundant. And at the same time, we had stumbled upon just a few patterns and techniques that, that make this a pretty common problem to solve. And we thought we could do a lot to help people understand that. So we launched a company a couple of years ago called Arpio, and as Lauren mentioned, Arpio is a global redundancy solution. Actually, Arpio is a disaster recovery solution for AWS workloads. We're not here to talk about Arpio today, but the point really I wanted to make is that global redundancy is something that's near and dear to my heart, and I'm really excited to get to share with you today what I've learned about the problem over the years, many years of my own career. So the way this is going to work, I'm going to do most of the talking today, but as Lauren mentioned, we invite you guys to ask questions. That's how we're going to tailor the content to your specific needs. So please do open up that Q&A box here in Zoom, and as you ask questions, Shaw is monitoring that, and he can answer some of those questions in real time, and then as we encounter questions that maybe we should be addressing more broadly, they'll bubble those up to me so that I can talk about those as part of this, okay? So without further ado, the goal today is to teach multi-region architectural patterns. So hopefully that's what you came to learn about. We've distilled a framework for thinking about multi-region architectures, and we're just going to lay out what that framework looks like and give you both the overall shape of that framework and also talk about some specific techniques that you can use in AWS environments to solve this problem for AWS workloads. So the framework isn't really AWS specific, but Amazon gives us a lot of services that we can take advantage of to make it easy to build multi-region applications. So that's the overall goal. But we really can't start by talking about the patterns. We need to start by talking about why this matters in the first place. So why should you care about multi-region redundancy? There are a lot of reasons why you might do multi-region workloads, and some of those are things like minimize latency for your end users by putting your workload near to them. Others would be things like data sovereignty, making sure that the data that you're managing in your application is stored in the right geography based on that. For example, GDPR stipulations around where EU citizen data can live. But we're talking here specifically about redundancy. And when we're talking about redundancy, it's all about availability. So we're going to focus today on architectures that give us availability in the face of region-wide AWS outages. And that sort of begs a question like, really, how often does an AWS region go down? And it's actually the case that Amazon has never entirely lost a region. But what is more common than you might expect is service outages, region-wide service outages. And if you've built a workload that depends upon given AWS services, and those services are unavailable in the region, then your workload is unavailable in the region. And you can see on this chart here, many of the more notorious region-wide outages, be it the load balancer outage of Christmas Eve a few years ago that ultimately took more than 48 hours for them to reconcile, or the infamous S3 outage that I know bit me in my last job, and where we spent 5 hours of downtime just hoping that Amazon could bring the service back up and that our data would still be there when we recovered. You'll notice in the last 12 months, we've had an increase in these service-wide outages. And the one that I've called out here in particular was back in January when there was a 7-hour outage of the VPC service in the Sydney region. And so for 7 hours, people who had built cloud forward workloads, elastic workloads that were adding and removing components as they were operating were unable to update the VPC service, and therefore unable to launch new servers and unable to run Lambda functions that were connected to a VPC, which was a pretty dramatic outage for those people. I don't know about you, I've sat through a couple 7-hour outages in my career. None of them have been very much fun. But all that said, the 7-hour outage is bad, but a lot of us are really more concerned about the catastrophic, the disastrous things that maybe haven't happened in the past, but they could happen in the future. They are rare, but if they do happen, they can be existential for our businesses. And for those reasons, we prepare for them. We're all very familiar with Black Swan events because we're living through one these days. None of us would have thought 6 months ago we'd be sitting, working from home, not able to interact with our neighbors and our colleagues like we were used to doing. And luckily, the pandemic hasn't affected AWS. It has had some effect in some ways on some of the other cloud providers, but Amazon's been pretty robust through it. But none of us know what's going to happen tomorrow. And if a catastrophic event were to take out the region that you're operating in your AWS services in, would you be able to recover your services? And would you be able to look the executive leadership, the board of your organization in the eye and explain to them why it was that the business couldn't operate for days, maybe weeks, maybe forever, depending on what the event was? So these things are rare, but because they're possible, we prepare for them. And it's really on us, the architects of these systems, to think through this. So before we actually dive in on the architectural patterns, we need to just kind of level set on one piece of the AWS architecture. And that is this concepts of regions and availability zones, something that you guys quite likely already really understand, but just to make sure that everybody's on the same page coming in, we want to hit on it. Amazon operates AWS in 24 different geographic regions around the globe. And each of those regions is composed of multiple data centers. Those data centers get exposed to us not as data centers, but as this logical concept called an availability zone. And the whole point here is that we should be engineering our workloads within these regions to be distributed across multiple availability zones. And if we do a good job of that, then there's a class of outages that might impact a full data center that our applications may be robust to. These are things like a fire in the data center, loss of cooling that might cause the hardware to start to fail and have to get shut down. Power outages seem to be a common one that impact data centers, and despite the fact that there are always backup generators, those generators seem to have a habit of failing an hour or two into the outages, bringing down the entire data center. So the first thing you should be doing as you're architecting AWS workloads is thinking about how am I going to deploy these across multiple availability zones so that you can be resilient to those forms of outages that might impact an entire data center. But if you want to be resilient to the next class of outages, and those could be things like metropolitan area disasters, like a Hurricane Sandy kind of event that impacted a huge number of data centers in the New York City region a few years ago. Or if you want to be resilient to various classes of logical failures. They're not physical failures where the data center failed, but maybe something more like what happened in Sydney, Australia back in January, where they actually had a database fail and had to be rebuilt. And for the 7 hours of that rebuilding process, they operated that service in a read-only model off of the replicas of the database. If you want to be resilient to those kinds of events, then you need to be building multi-region workloads. And the great thing about the AWS region architecture is that regions are completely independent. So a failure within a given region should not impact any of the other regions. While there is some shared infrastructure within a region across availability zones, there is no shared infrastructure between regions. So taking your AWS workloads and being able to replicate them or operate them in parallel in multiple regions gives you resiliency to the full class of outages that you might be concerned about within a geography. So that's kind of regions and availability zones. Let's talk about architectural patterns. So there are fundamentally just two architectural patterns for you to be aware of when you're thinking about multi-region redundancy. And these aren't necessarily the patterns that you'd think about if you're going multi-region for reasons of latency or data sovereignty like we talked about. But rather, if we want to make sure that we're resilient to region-wide events, any kind of catastrophe that could impact our AWS workloads, it's really two ways to go. The first, the multi-region active pattern, it's pretty self-explanatory. You have workload running across multiple regions. Your users can interact with your workload in any of those regions and get an equivalent experience regardless of which one they interact with. It's not necessarily an identical experience, but it's functionally equivalent. The other pattern, the cross-region failover pattern, your users interact with your primary region, and assuming that region is healthy, everything works for them to just interact in that one way. But if a region has a catastrophic event, or if a region-wide service outage happens and you need to be able to get your service back up and running and not wait to figure out how long Amazon's going to take to restore that, then you can fail over to an alternate region and continue operating your business that way. So we're going to walk through both of these patterns and look at them from three specific design perspectives. And those are, first, how should we route our users to the appropriate region based on where they are, based on the application level concerns that we have? The second is, how do we synchronize our data between the regions so that users interacting with one region and then maybe failing over to another region get an equivalent experience to what they had before the failover or before they switched regions? And then the third one is, where do we run background jobs? It's not every application, but many applications have some concept of a batch job or background job, nightly job kind of thing. And when we're thinking about multi-region architectures, we have to be considerate of which region are those particular jobs going to run in, and how do we fail those over to another region if that's appropriate for that. So we're going to look at both of these architectures from these three specific lenses, and give you some tips, explain to you like what we do and what we've seen in having solved this problem with dozens of other customers, and how they're solving these particular problems. So before I dive in there, I'm going to take a quick breath and just ask, hey Shaw, are there any questions coming up that we should be addressing at this point?
Nothing in the queue right now.
Okay, so I do want to encourage everyone to ask questions as we go. That's really what's going to help us to tailor this specifically to what you guys are looking for, okay? So without further ado, let's start by talking about multi-region active architectures, okay? So the first question that we want to answer when we think about both of these architectures is, how are we going to route our users to the appropriate region? And there's a few different ways that you can do this with the multi-region active architecture. You could just have it baked into your client that there are 2-3 regions out there, and the client understands how to go contact all 3 of them and find one that is currently working for it. Amazon also has a service, the Global Accelerator service that they released, I think it's actually 2 years old almost. And in that particular case, they will take the IP address for your application and route it to the appropriate region. So one IP endpoint can route to multiple different regions. But in working with customers, the way we see this problem solved most often is to leverage an intelligent DNS service, to have the DNS system serve up IP addresses as appropriate for your users. And generally when you do this, you'll oftentimes hear the term global server load balancing. This is the GSLB is sort of this class of intelligent DNS services that are out there that can do things like evaluate the geolocation of the end user, or the latency between the end user and the various regions, and serve up the best IP address for that user to be interacting with. And as part of doing that, they can also bake in the ability to validate the health of the service behind that IP address to understand whether or not we really should be serving up that IP address. So Route 53 is Amazon's DNS service, and it has a fantastic solution for global server load balancing built into it. You can use all kinds of strategies to serve up the best IP address for your users depending on where they are in the world. But in particular, it can leverage health checks to understand whether your service is healthy in that region. And you can build out your own health check infrastructure, or if you're using other Amazon services like the load balancing, application load balancer, network load balancer, Route 53 can look at the health checks that are baked into those applications and understand whether or not those are healthy and those IP addresses should be getting served. So in that particular case, if a region has an outage or the application in the region goes unhealthy for some reason, Route 53 just stops serving up that particular IP address, and the customers fail over to the healthy region that's left behind. Now this failover is not immediate. It does take time both for the health checks to start failing, and a lot of this depends on how you've defined your health checks and how many failures in a row need to happen, how frequently health checks are happening. But generally you can expect that it's a minute or 2 before the application registers as unhealthy. And at that point in time, Route 53 would stop serving up the IP addresses for that particular region. But you will have some users who already have those IP addresses from previous DNS queries, and you'll need to wait for those to expire, which depending on how you've set up the DNS might be as short as a minute, but it could be 5 minutes. Some people have set up DNS to cache much longer. If you're thinking about being able to fail over to another region, you need to think through what is the time to live on the DNS entries, so that when we do stop serving a given IP address, our customers our users will come back and request an updated IP address in an appropriate time frame. But in general, there is no such thing as a zero downtime multi-region workload. There's always going to be some amount of downtime associated with detecting the health check failures. And if you're using DNS in order to fail your users over to another region, then you also have to factor in the TTL on the DNS entries. So that's the common way we see people doing request routing in a multi-region active application. The next thing to talk about is data synchronization. And this is really where the rubber hits the road with a multi-region active application. And it really comes down to the fact that if you're doing a multi-region active application, you need to embrace a multi-region data store. This is a data store that allows your users to interact in either region to make updates to the data within those regions, and then it will synchronize those updates to other regions where the application is running. So it's a multi-master workload, and because of some theories of computer science that we're not really going to dive into, these databases are always eventually consistent databases. And because of that, you can have conflicts occur. It is possible for users interacting at about the same time with different regions to make competing updates to your database, and then the synchronization fails or some application level consistency is broken. And you have to embrace dealing with conflicts in order to build a multi-region active application. What this means is that generally multi-region active is baked in from the conception of your architecture. It's usually not possible, it's certainly not easy to take an existing workload that wasn't built with this concept in mind and then go and tack it on. For those workloads, generally the cross-region failover is the more pragmatic approach, and we'll talk about that in a second. Now, there are in AWS a couple of different database solutions or data stores that you can use that give you multi-master writability across regions. The first is DynamoDB with the global tables enabled on it. So in that particular case, you use DynamoDB to create tables in multiple regions. You configure those as global tables to replicate to each other. And then updates happen within each individual region. DynamoDB handles replicating the data between those in an eventually consistent manner. DynamoDB has a built-in conflict mitigation approach, which just says the latest update wins. So if you were doing things like maybe you're selling concert tickets through your application, and two people buy the same ticket in the same period of time for the same seat at the concert, and then synchronization happens, the second one to actually get that purchase through before the synchronization happened is the person that gets that ticket. And you now have to figure out how to find the person who lost the seat and track them down and explain to them eventual consistency in your database. It's not an easy conversation to have. So those kinds of workloads that require really strong consistency become really difficult to do in these kinds of examples like this. The second data store you can use in AWS to do multi-master across regions is S3. It's not a database, but it is a data store, and you can take your S3 buckets, create 2 buckets in 2 different regions, and configure them to replicate to each other. And then when objects get updated in one bucket, they replicate over to another. There's a service level agreement that Amazon says, I think it's 99.9% of objects will update within 15 minutes to the other region. So there's a decent amount of latency in getting those objects replicated to the other region, but it is a possibility for a multi-master data store. Usually we find that people aren't using this alone. They're using it in conjunction with DynamoDB or some other database. And they're just storing blob data objects in S3 and then the structured data over in their database and replicating those together. The third option that you have is various databases that you can run yourself on EC2. And there are many database platforms out there, and a lot of them have some story to tell about multi-master distributed workloads. And so you can run those yourself on EC2, just like you could run them in your own data centers. I guess, my own opinion on this is that doing this well is a really difficult thing. And it's not just getting it set up and configured correctly, but it's dealing with all the operational anomalies happen when you've got a network hiccup and synchronization doesn't happen for some period of time, when you've got conflicts that get introduced and every database platform deals with them differently. So I encourage people when we talk to them about this that don't take this one lightly. If you're going to go this route, make sure that you've staffed your team appropriately to be able to deal with all these operational anomalies that can happen. Now, aside from these, none of the managed database platforms in AWS support multi-region master. There are things like Aurora has a multi-region solution, but it's read-only in all regions but one. It's only writable in a single region. And then some of the other managed databases like the DocumentDB, which is Amazon's MongoDB, or Keyspaces is their new Cassandra compatible, I presume is Cassandra under the covers database. While those platforms, Mongo and Cassandra, do have a story to tell about multi-region replication, Amazon's managed database services themselves don't expose that capability today. Maybe coming in the future. So the last thing we need to talk about when we're talking about these different architectures is how do we handle background jobs? And again, the challenge that we have here is knowing which region should we be running a given job in. And if you think back to the way background jobs were done 20, 30 years ago, in a lot of cases still are done today, you have systems like cron on Windows. It's a scheduled task that is just going to perform some operation periodically based on a schedule. And those things work really well until we start to get concerned about high availability and what do we do in the event of a node failure where this machine hosting this cron job is no longer available. In those situations, it's pretty common to introduce, and I need to not hit the space bar because it seems to advance twice, but it's, in these situations, it's pretty common to introduce a job queue. And in this particular case, we have a centralized job queue. We've got multiple job agents, and those agents are pulling jobs out of the queue. They own that job, and they process that particular job until it's complete. And this allows us to be resilient to the failure of a single node because other nodes running other agents would just pick up those particular jobs and continue running. Now, the thing about a job queue is that it relies on the fact that when a job agent claims a job, it's now locked down and another agent can't claim that same job. And fundamentally, that depends on the concept of strong consistency in the job queue. We need to have some sort of transaction or something by which the job agent is claiming a job in the job queue. And if you remember, the 2 slides ago, we don't get strong consistency across regions in a multi-region active workload. And therefore, we can't have a job queue that spans multiple regions. So what ends up happening functionally is people embrace the idea of failing over their job queues to another region. So even though this is a multi-region active architecture, for handling jobs, the way that people generally do this is the jobs run in a dedicated region. And if that region is impaired for some reason, the jobs can be failed over, usually manually, to another region where they can then be picked up and running. And the reason why this is usually okay is that jobs are a little less time sensitive than your transactional workload that your end users are experiencing. And so if it takes us an hour to fail over our job queue to a different region and continue processing jobs, then yeah, some jobs run an hour later than they usually would. But depending on the business context, that quite likely isn't actually a problem. And so this is a fine solution for those situations. So that is the multi-region active architectural pattern. And I'm going to ask Kyle one more time. Do we have any questions that we should
We do. We have one that I think fits in right now that we've covered this. We have a question. To what extent do we need to handle multi-region redundancy for serverless architectures?
Yeah, so it's a great question because generally if you're running serverless, you're running either Lambda or you're running maybe a Fargate workloads, containerized workloads on Fargate. And those, Lambda and Fargate, I know Lambda in particular, it's a region-wide outage and a region-wide service. And therefore, if an availability zone goes down, Lambda just picks up and continues operating in a different availability zone for you. I guess I'd point out, I think it was in April, there was a 3-hour outage across the Tokyo region of the Lambda service. And I don't honestly, Amazon didn't do a root cause analysis and divulge exactly what happened in this particular case. But if you look at region-wide services in AWS, those region-wide services are running in the same availability zones that your other workloads would be running in. It's just that Amazon is running it for you. And so they've taken on the heavy lift of figuring out how do we provide resiliency across availability zones here. And in the case of the VPC outage in Sydney, the solution they had wasn't good enough. They had a writable database in one AZ that was replicating to other AZs. And when that writable database failed, they had to rebuild that database and then run the service off of the read replicas in the other availability zones for that time period. And so all that's really just to say that region-wide services can still have outages, and when they do have outages, they're generally region-wide outages. So for your serverless workloads, it's every bit as relevant as it is for the workloads that you might be running on servers in availability zones. All right, Shai, I hope that answered that question. Anything else before we move on?
No, that was the only one that's queued up.
Okay, great. So we're now going to talk about cross-region failover. Cross-region failover is a simpler pattern. And so we'll get through this one, I think, a little bit faster than the multi-region. So when we're looking at multi-region, we were talking about leveraging DNS with health checks to route users to the correct region. In the cross-region failover scenario, we can also use DNS to route users to the correct region. And generally, it's a very static routing because the users are generally all going to a dedicated region where we are running our applications. If that region does have any sort of failure, then what we need to do is simply update the DNS entries and direct them to the other region where our application is operating. And after that same TTL expiration that we talked about with multi-region active, then users will start to fail over to this other region. Now, what's really important here is you're not going to make that IP address update until you've got the service up and running in that other region. So how long you're actually down is a function of how long does it take you to bring your service up in another region. So that can be as fast as minutes. And if you've invested a lot in automation around your AWS environment, then you can bring up your AWS infrastructure and restore your data within that infrastructure in 15, 20 minutes, depending on what services you're running and what your data looks like and stuff like that. So it can actually be a reasonably quick exercise to fail over to another region, but you have to have invested in that. If you don't invest in it, it could be days. It's pretty common that when we're talking to our customers, they have a manual failover process. They've got a lot of automation in place, but they haven't automated the end-to-end DR scenario. And therefore, it's going to take them 24 hours to go and recreate everything, get their backups restored in place, wire up everything that wasn't previously automated, and figure out all the kinks and get everything failed over. So really, fundamentally, what I'm trying to get across to you guys is that automation is your friend in the cross-region failover scenario. And if you want to do it really well, you need to be focused on how do we automate bringing up our applications. The nice thing about the cross-region failover scenario really comes in at the database layer, because unlike multi-region active, where we had to embrace in our architecture a multi-region, multi-master database, we can use traditional data stores for cross-region failover. And we just rely on simple backup and restore of those databases, or cross-region replication, but one direction replication like you might have with a read replica, in order to get the data from your first region over into your failover region. Obviously, this needs to be happening continuously, so that your data is fresh and up to date in your failover region. But you can do this with your workloads that are built with MySQL and Postgres and SQL Server and Oracle, whatever your relational database of choice is. And you can also do this with your workloads that are using either NoSQL, or maybe it's an application that has some opaque built-in data storage. It's not a traditional database platform that you're running, and you need to be able to fail that over. So the benefits of the cross-region failover are really about being able to apply this pattern to existing workloads or to new workloads that you're building on traditional data stores. So beyond that, we talk about the background jobs. And this is where I mean, you've seen this slide before. With the multi-region active pattern, we embraced a cross-region failover solution for background jobs. So that exact same solution obviously applies with the cross-region failover pattern. So as I mentioned before, you have a job queue running inside of a region, and you've got the ability to replicate the queue to another region continuously. And when a failover needs to happen, you bring up your agents in that other region, reading from the queue locally in that region to continue processing those jobs. So that is the overall framework that we wanted to teach you guys today. And just to quickly summarize it, there are two architectural patterns for multi-region redundancy that you can choose between: the multi-region active pattern and the cross-region failover pattern. Their names are very intuitive, so I imagine just saying them, you understand what we're talking about. As far as how we do these three different dimensions, which we care about anytime we're solving a multi-region redundant application, request routing, generally we see this done via DNS, either using a sophisticated DNS solution like Route 53 and leveraging health checks in the multi-region active, or with a much simpler solution of just updating DNS entries in the cross-region failover scenario. From a data synchronization perspective, this is really, as I mentioned, where the rubber hits the road. If you want to do multi-region active, you have to embrace a multi-master data store that can replicate across multiple regions as changes are being made within those different regions. If you have an existing workload or you're building a new workload with traditional data stores, then the cross-region failover is generally the approach that you're going to take, so that you don't have to re-architect your application with a totally different data store. In that particular case, you can leverage backup and restore or cross-region read replicas in order to get the data synchronized to the alternate region. And in both of these scenarios, your background jobs are going to run in a dedicated region and fail over to an alternate region in the event that your dedicated region is unavailable. And that's generally a manual failover process. It might take an hour or two depending on how you've set up things, how automated it really is. But for background jobs, we usually find that particular delay in executing those is not significant given the catastrophe that you're averting by failing over to another region. So a couple more things before we finish up and see if we can answer some more questions. A couple months ago, Amazon released a reference architecture for multi-region applications. And I would encourage you guys to go out and take a look at what they've done here. It's in their AWS solution implementation stuff. If you just Google that, you'll find it. I'm going to send out these slides to everybody afterwards, and you can just take the link that's in here. The thing I really want you to notice with this is that this multi-region application architecture is a cross-region failover architecture. And so even Amazon has now chosen to embrace the multi-region active with this, this reference architecture they've put together. In this particular case, let me talk about the three design considerations that we've talked about here. The way that they do request routing is actually, they have it in their client, where their client knows to contact a primary region, and if it fails to contact a primary region, it knows how to contact the secondary region. So they did not use Route 53 DNS entries to do this. And I think that's largely because it's simpler for them to not have to include Route 53 in the architecture. As soon as you put Route 53 in, now people have to have their own domains registered that we can create DNS entries for, and so it just becomes much more difficult for people to just pick this up and experiment with it. But that is a valid way to do this, is to have your clients know about the various regions and have the client deal with failover on that side. For the data synchronization here, they're using DynamoDB with global tables, and they're using S3 bucket replication for their data storage here. So you'll notice those are the two services that we were advocating would be part of a multi-region active architecture if you're using Amazon's built-in services. But they've still chosen a cross-region failover solution here. And I think if you peel back the covers, it's because they're also using Cognito for their user store here. And Cognito is notoriously difficult to set up in a multi-region manner. And there is no multi-region, multi-master Cognito capability here. They actually have set this up so that when you create a user in the primary region, they've got a Lambda function that triggers to go and create an analogous user in the secondary region. But they can't replicate the passwords because those passwords are locked up in Cognito. You can't get to them. And therefore, if they ever have a failover, users have to do a password reset in that failover region in order to continue using the application. So that's the data synchronization story with this. And then there is no background jobs built into this application. This application is just a simple photo sharing application. It's a pretty generic way that people like to do sample apps. And there was no background jobs to process in here, so they didn't need to tackle that particular problem. And then the last thing that I want to make sure that I tell you about is that the company I lead, Arpio, we do multi-region redundancy for AWS, and we make it really easy. You connect us to your AWS environment, and we find everything that needs to be replicated, both all of your infrastructure as well as all of your data. And then we set up a standby environment that you can fail over to. And so it gives you global redundancy that you don't have to build yourself. You don't have to figure out how to solve these problems. Arpio's figured that out for you. It also gives you the ability to have vaulted data protection. So we're not talking about all forms of disasters here, but the most prevalent kind of a disaster we see in IT is cyber attacks, ransomware. And to protect against those, you need to have your data backed up in a location that the cyber attacker can't compromise. And so Arpio gives you a vaulted data protection of your recovery environment, so that if you were to get hacked, your recovery environment is not hacked. Everything is automated, so you don't have to go build your own automation. Generally, our failovers happen in minutes. Depends on the workloads you're running, but you hit the failover button in Arpio and you can be back up and running in 5-10 minutes. And it's very cost efficient to do this well in AWS and not have to spend a lot of additional AWS costs. You have to really understand things like incremental data snapshotting and the right way to manage KMS keys so that data transfers are incremental. And we've figured out all of those hard problems so that you don't have to do it. So this isn't supposed to be a sales pitch for Arpio, but I think we've done a great job solving this problem. And if you're interested and would like to know more about how we're doing this, or if we can help you solve your own multi-region redundancy problems, we'd love to have a chance to chat with you. So that said, that is the end of this. We've got about 10 minutes left to address some more questions. So
well, I've got one queued up. It's been sitting here for a little while, but I think it's a good time to kind of circle back. So the question is about database read replicas. Can they be multi-zone was the question. And I think that might be good to address in sort of an AZ way, but also a multi-region way. So when we're talking about traditional read aliases, read replicas on your database.
Yeah, okay. So first off, we should say you could be doing a read replica yourself by running your own EC2 instances, or you could be using maybe RDS to do the read replicas. So I'm going to take it from both those, and then I will, to Shaw's point, talk about both multi-AZ within a region, like a replica in another AZ, as well as having a replica in a different region and what its AZ story could be. So, so if you're running your own database in EC2, then yes, if that database technology supports replication, you can have a read replica, and you can set that read replica up in a different availability zone. And if you're doing this for availability reasons, you should do that, and then have the replication happen across AZs. And that way, if you lose your primary availability zone, you can promote the replica to be your master database and continue operating your workload against that. Similarly, you could set that replica up in a different region, which is by definition going to be a different availability zone. And that would give you further resilience to a multi-AZ outage or a region-wide outage, so that you could fail over to a different region. I mean, if you're going to go through all the effort to set up a replica, there's very limited reasons I would think why you wouldn't just choose to set that up in a different region so that you've got a higher level of resilience than you'd get by staying within your region. Now, if you're using RDS to manage your data, if the relational database service of Amazon is hosting your database, then you have built into that as a checkbox that you can check to say, make this a multi-AZ database. And in that particular case, Amazon is going to fail over automatically to another AZ, the database, when if your primary database were to go down for any reason. And they do that failover automatically. They manage the IP addresses behind the host name that you're connecting to, and they would update the IP address so that that host name now points at the failed over database. And your application would presumably start getting errors and connecting to the primary database. It would go through some process of reconnecting, and when it reconnects, it would connect now to the other database. Now that's the right way to do multi-AZ within a region for RDS. It does double your RDS costs, but it's if you're running a production workload in RDS, I think it's just a given that you should be doing that. If you then, though, want to be resilient to multiple AZs going down within the region, you can set up RDS. If you're using Postgres and MySQL and MariaDB, you can use RDS to replicate to a read replica in another region. Or if you're using any of the RDS database engines, you can use RDS database snapshots to snapshot the data and to copy those into the other region. And in both those cases, you've got your data staged in another region that you can then restore your service in the other region in the event of a multi-AZ outage. Hopefully somewhere in there I hit on the right answers to that particular question there. Shaw, are we seeing any other questions yet?
That was the last one.
Right.
If we've got any others, we've still got a few minutes, so we're happy to
yeah, and I guess I'll just wrap up by saying, we'd love to have a conversation with you and help you understand any questions that you maybe aren't comfortable asking here right now. This is part of a series of AWS architectural talks that we're doing. And so if you're interested in getting notified of those, we'd say out on LinkedIn, you can find the Arpio company site, and just follow us on LinkedIn. And as we post these things out there, you'll have a chance to come in and see those. And we'll also make the recordings of these available in case you're interested and you can't come to the actual event.
So Doug, I've just got one question that just popped up. I'm not sure I fully understand this. Maybe you can help me. How does the read replica solve for the write redundancy in a multi-region redundant?
Yeah, okay. So I think the question is, so I've got a read replica in another region. It's a read replica. How am I going to write to that? So it's a great question. I've probably just totally messed up in explaining this. you can take a read replica and promote it to be writable. And so in your cross-region failover scenario, having a read replica in another region, part of the failover process is to then promote that to be a writable database. And at that point in time, you can go and make all the changes that you would otherwise be making in your primary region to that. It doesn't solve problems like, you know, if I've got within my region, I've got one writable database and I've got several read replicas. My read replica in the other region, after I promote it, I still need to go create a bunch of read replicas of it to be able to handle and scale out my workloads on that. But the fundamentally, the whole point of that read replica in the other region is so that you've got the data there, and then you can promote that to be writable in the event that you need to fail over.
Great. And a quick follow-up, would that automatic transition, or would it be an automatic transition, or would it need a manual intervention?
That would require a manual intervention. Somebody needs to go in and hit the button to say promote this to be to be writable. Generally, it gets to the question of, should my cross-region failover architecture be an automated failover or a manual failover? And it turns out it's really difficult to accurately assess the health of your production region and determine whether or not you should automate the failover. And since those failovers generally have some downtime associated with them, and then they introduce the problem of how am I going to fail back to the production region, you don't want to do that lightly. So you want to generally have a person involved that is going to say, yes, this particular outage meets our criteria for cross-region failover. And then they're going to push the button to launch whatever automation, or they're going to push all the buttons necessarily to manually do that. And part of that would be to promote that read replica to be writable at that point in time.
Great. Well, I think that's the last of the queued up questions.
Great, awesome. Well, thank you guys so much for sharing some time with us today. I hope you learned some stuff out of this. And if there's any other questions that you've got, please reach out to us, let us know. We'd love to help you solve this particular problem for your workloads. All right, thanks so much, guys. Have a great day.